Hello, everybody. Good morning, or good afternoon, or good evening, depending where you live. My name is Nico. I worked for Golem, and I'm gonna be your host for the next hour or so. And at the same time, also Alex is also connected, is moderating the chat box. So if at any time you're having any comment, any questions, feel free to put it into the chat box, and after that session, we'll probably run a question and answer sessions about what I'm doing, or maybe if you have other questions, that's what I'm showing. So today is going to be about flocking, so you can see more or less what we'd like to achieve after the 30 minutes. So that's just a quick scene I made with a couple of beast characters animated. Following, you can see a curve and also wandering around kind of a beehive. And just for more people to join, in the meantime, let me remind you that starting next week, we're gonna do a 4 sessions battle live presentations. So we're gonna have 2 next week and 2 the week after. And next week it's going to be about, on Thursday we'll do archery, so soldiers emitting characters and hitting other characters with some physics and some emit behaviors. And on Friday we're going to do charging armies, so if you ever wondered how to have 2 facing armies charging to each other, that would be the perfect session. And the week after we'll probably make formations and cavalry, and also a session about converging and putting everything within the same scene. So let's get started. So this is the final scene here, and obviously I want to start from scratch. So this is what I want to achieve, and let me probably open another scene there, which will be the init state I want to start from. Just a side word, by the way, that scene and that asset will be pretty soon. There will be also added to the character pack. So right now those are assets I made myself, but we're gonna embed them into the character pack into probably the next release. So yeah, stay tuned if you want to be able to actually see the final scene instead of doing it yourself. So what's in my scene so far? I'm having an entity type as usually. That entity type is my type of character here, and what I'm gonna use into that scene is gonna be a bee character. Maybe let me show you how that guy looks like. So it looks like this, and I can probably show you the skeleton. So nothing really fancy here, the different legs, and well, you know what? Let's switch into that view here so we can see how I actually rigged it. So yeah, once again, nothing really fancy. I'm having the different legs there, and also here, because probably I wanted to make some physics with the character, I also mapped the wings. So there's a controller for the wings, just a one bone, which controls the forewing and the hindwing, left and right. So there's 4 different wings on that character here to control, and yeah, I just mapped it so I'm able to actually physicalize it. So yeah, the character is a bit bigger than the one I'm using into the scene. I just rescaled it, but this is more or less how it's looking like. So you can see I make some physics shape as well, because I wanted to add physics to that scene. So yeah, I loaded that character into an entity type, and just to save some time for today's session, I'll also added a motion. So let me show you how does the motion looks like. So it's just a posture. I'm not an animator, but that's just a posture I made of the different legs being folded a bit, so it looks more natural. And also you can see the root bone is kind of making that sine wave, which could be characteristic of flying insects. And you can see the wings, which are here. They're not animated yet, so that's the second part here. So I'm having that motion clip, and when I apply that clip to my character, you can see, yeah, the legs get folded. There's that noise of the rune going up and down. Also the abdomen is moving slightly, it's noised. So what about the wings? For the wings, then I decided to animate them procedurally. So I'm using the SetBone Behavior here. So the SetBone behavior allows me to specify a name of a bone and to specify some, some values. And you can see I just apply an offset because the wings are not exactly going to be animated into that axis. So I just offset them so they're a bit above the character. And I also added an animation here, so noised animation based on a ramp. So I just draw a ramp here which will be executed on 8 frames, which will have a value between minus 160 degrees and 0. And it's just going at 160, 0, 160, 0, etc, etc. So if I enable that behavior here, so that's my complete animation. So the wings are going to be animated with that procedural animation here, which I can change if I want to, and the rest of the body will be animated with my motion clip. So far, so good. What else do we have? I think that's pretty it. I haven't defined any environment. I wanted to do it while you're here. And I just draw, a curve here and also a kind of eye I want my characters to wander around. So let's take a look at the different behaviors we're having. So remember, if you attended the previous session, we were playing with, as always, go to behavior to go somewhere and navigate to avoid the other characters. But that behavior is actually dedicated, well, those behaviors are actually dedicated for 2D and a half animation simulation. So what 2D and a half means, it means basically characters which are moving on the ground, which gets adapted to a ground and don't navigate on the y-axis. Whereas here I'm gonna do some bees, and obviously those guys are gonna navigate on the let's see. Okay. So apparently the sounds get again. I'm not sure where the sounds get. So let me know what was the last word you heard, or what was the last phrase you heard. Apparently the sound has been off for quite a while. So I'm just waiting for anybody in the chat box just to let me know what was the last thing you heard, and I'll start again from that point. Sorry about that. We changed the cable, so apparently that's not a cable problem. So go ahead. Okay, great. So not so long. Thank you, Lucille. Characters are gonna move on the y-axis here. So I don't want them to use those behaviors, the go-to and the navigation behavior. Instead, I want to use 3D navigation behaviors. So this is gonna be the whole purpose of the steer and the flock behaviors. So let me just drag and drop those there. So I'm gonna drag the steer behavior first. As always, it's kind of a go-to target behavior, so it has some attributes to reach a specific target. But here my target will be a 3D target. So maybe just a bit different. We're having something called weights, which means you can have multiple targets at the same time. And you can just specify what's going to be the weight of each target. So when characters get closer to a target, they may be attracted or repulsed by a target. So it's really up to you. So that's something you can really play with when you do with 3D characters. And within the mode, there's actually 3 modes. So within the go-to behaviors, there's just 2, which is reach and flee. Here, within the steer behavior, we've got something which is called wander. Wander just means that they'll pick... they're not going to pick a random target. They're just going to wander around the area. So they're just going to move while staying within the area, following the rules. So they don't really specifically target a point. They just wander around. So that's exactly what that wander means. Obviously, you can reach. And reach allows you to reach almost the same attributes than what you're having with the regular go-to, which is either 3D position, or a curve, or an expression, or a PP attribute, or whatever. And you're having all the casual, attributes to set what you want to reach. So here, I actually want my characters to follow that curve I've been drawing here. So I'm gonna, as always, you kind of get used to that now. As always, I can select my curve here, select my steer behavior. I want to say that what I want to use is a follow curve behavior. I want to map my curve in it. And now I can say that I want to assign my curve. So if I had multiple curves, I could say which one I would like to pick. What's my start mode? So I have not emitted my characters first, but the start point is going to be probably here and there. So I want them to start from the closest point they can find. And I want to sample my curve with 20 samples around the curves will be nice. And what's going to be the target reach threshold? So under which distance we're going to consider that the characters reach their position. So my scale is quite big. I'm going to put a half value here. And do I want my characters to loop following the curves at when they reach the end? So yes, totally. So let's see how it goes. So first, I want to populate my characters here. I just have one guy, which is here. But I want to probably put more of those guys. So once again, I can use the population tool. And if you may remind, those tools I was using so far, they're actually also dedicated to 2D and half simulation. So they allow you to draw a box, but which is a 2D box, circle. So we could make a mesh and maybe populate within the mesh, so within the vertices. So we can make a volumetric mesh such as a sphere, select the vertices here and say you want to populate on the vertices, or you can just use the 3D sphere creation locator. So I'm just gonna set into that mode here. I probably want to put it somewhere like here, and what you're drawing here is gonna be now a sphere, so it's gonna be a 3D character emitter. I want to populate my sphere here with 600 entities, so I can see the characters which are within the middle. If you're not really happy with the display, you can probably change the transparency of the. Well, that's changing the transparency of everything. Okay, but just to have a better view of what's going on here, not ideal, but still you can get a sense of what's going on. As always, you can change the distance, you can change the orientation, and when you're happy with that, you just press create, and that just creates that cloud of particles. When each of those guys here is going to be a B character. So here I just set them with a target, but if you've been following the previous session, you already know that that guy by himself is not sufficient. I actually need to specify what's the steering strategy. And when we speak about 3D characters such as fishes, birds, insects, or maybe herds of animals, the current word for that is called flocking. So we're having a behavior which is called behavior flock, and that's exactly what that behavior is about. So making the steering of the character in 3D mode. So I'm just drag and dropping that node at the same time, so it means that characters will go somewhere, they're gonna flock, so I have an avoidance strategy and also apply some speed and acceleration. They're also gonna have procedural animation on the wings, and they also have just a regular clip on the rest of the body. Just a quick word about the flock. The flock algorithm is quite old. It's been developed by a researcher in 1986 called Craig Reynolds. And that's just based on his observations of actual birds, clouds of birds, herds of birds. And he was trying to simulate those, so figuring what will be the right parameters to simulate and reproduce those. So he figured that there's 3 parameters you can play with. One which is separation, so how far you want to be from the other characters within the scene, within the flock. But also something called cohesion, so separation means the character will tend to go far from each other. Another which is called cohesion, so how close you want to stay within the other characters. So sometimes you want to get at the specific distance but stay at the specific distance, so that's something called cohesion. And also something called alignment, so do the characters tend to be aligned with each other? So when you look at a flock of birds, you can actually pretty decide what they do depending on just just those three parameters. And that's exactly something which are exposed within the flocking behavior. So we get the separation weight here, alignment, and cohesion. And on top of that, your characters have some kind of, I'm going to say, physics properties which define what their speed and how much they accelerate. So there's something which is called the mass. So the mass is just the actual weight, the actual mass of the character. You can also have something which is called the force, which is going to be the magnitude of the changing of the character, and the max speed as well. So let's just stick with those default attributes so far and see if we need to change anything. So here we're emitting the characters, and they're just picking the closest point and just follow that curve and made a really tidy block of characters. They don't change much here. They're not going really fast neither. I will actually think that bees go faster, but they do actually follow the curve as a kind of inertia here, which I guess we'll have to tune the parameters to get something which will be a bit better. So I actually want them to be more reactive to the trajectory of the curve, so I'm going to increase just the force. So I'm going to probably change almost the order of magnitude here, go to 1790, something like this. And you'll see that by just changing the force, you'll get something which is, when we'll get close to the sharp turns, we'll get something which is really closer to the territory here. I probably want to increase the speed because it's not getting faster enough here, so I'm going to pump that speed a bit. Let's see how it goes. So I'm just specifying a range between 12 and 17 here, and you can see now the characters get a bit faster. It's maybe not enough for me. Let's say to 1821 there. Here we go. And here they probably a bit too much tidy for me. They're too much grouped. So as you may have figured, what I want to change here, because they're too close to each other, is probably the separation weight. I want them to be more separated, to have something which will be more expanded amongst the whole curve following. So I'm just gonna pump the separation weight here. I'm gonna double it. So remember, my characters were like really packed next to each other. Fortunately, hopefully, if I turn on the separation, yeah, okay, that's better. You can see it's less dense, very more like scattered, but still follow the curve, but more scattered here. Okay, not bad. I'm quite happy with that. Second part of my and there's that tiny guy here who probably like started from the origin, and which is kind of lagging behind. So yeah, okay, not bad. Probably need some pre-roll frames to have something more scattered along the way, but it's actually doing a pretty good job. So here, let's say this is going to be a beehive, and I want my characters also to wander around. So what I'm going to do is probably make a target next to it and ask them to just reach that target. Oh, and by the way, something I totally have forgot to speak about is probably you notice that around my environment there's that orange lines which looks like a sphere. If you were there during the session we made 2 days ago about traffic, I was mentioning something we called environment within Golaem. So we're having plenty of environment, and one is the flock environment. So obviously when you do 3D navigation of characters, you want to specify what's the word you can live within. So whenever you are actually drag and drop steering and flocking behaviors, it automatically creates for you a flock locator. So this is the environment of your characters, and if you so this is the actual limits of the word of the character. So if you need them to be able to go beyond that area, you need to pump that flock radius. This is also where you'll be able to specify some perception attribute and also some obstacles here, and I'm going to totally use that to specify some obstacles because I want my characters to be able to both go at the same time to the beehive but not collide with it. So let me add a target here, and that target is probably been created here at the middle of my environment. And what I want to do is actually put that target within the middle of my beehive. Okay, and what I want to do is bring another steer behavior here. I want that steer behavior to reach. The position I want to reach is the target shape I just created, which is probably target shape 2. That was the actual, let me check. That was the red node, so that's okay. And I want my characters to randomly pick either going following the curve or actually going reaching that 3D position. So I'm gonna so if I want to do that, it means that I need to add a random operator here to be able to make that choice. So I'm gonna bring a random operator, put it in front, so I'll be able to make a choice between some direction and some other. You can see it created for me automatically like a group operator in which I can design more complex stuff. So I'm gonna just drag and drop this into my group, jump into it, and now I'm gonna say, okay, I want my characters to either follow the curve or reach my target position. And on the random, I can control how many I want those to follow the curve. So what are going to be the chances for characters to follow the curve? So by default, the weights are going to be similar. So it means half of my crowd will go there, the other half will go here. So let's check how it goes. So it means that now I'll have less character following the curve and characters separating to go directly to the targets. And this is exactly what I was expecting. Here you can see my characters, they actually collide with the beehive and not avoiding it at all. They're just trying to follow the target. And as soon as they actually reach the target, they just wander around. So they just stay around and play their behaviors. So what I want to do here is actually specify that this is going to be an obstacles, even if there's a target which is within the zone here. I want this to be avoided. So I'm going to take that mesh here. I'm going to go into my flock locator, press Control to be able to keep the two selections, and I'm going to add the mesh within the obstacles. So just a quick word about that. What we're going to do here to make the obstacles avoidance is going to be we're going to look at the normal of the geometry. So here you can see that character, well, that geometry here, the beehive here, it has normal pointing out. That's the default way the cylinders are made. And those normals are going to act as a repulsion factor. So it's going to repulse the characters. So if you want to make obstacles for 3D characters, you really want to make sure that your meshes are kind of rounded all the way around. Let's say you just have a cube. The normal of the cube are pretty sharp, so it means that when characters will be on corners, they won't have any normal information to take care of. So it's always better if you got something which is rounded and don't have too much sharp edges. So by the way, if your obstacles are dynamic, so it means that if they're moving or deforming, you want to make sure that you're checking that box. Once again, it's just an optimization we're having. We just make sure that we don't read data from Maya too often. So by default, we consider that that obstacles are not animated. Feel free to change that if you want to. So let's take a look here. How it's going. So now I'm having still my half of characters, going to the beehive, but you can see here they're not going through it anymore. They just wander around and they're not colliding with it anymore. Let's stop this for a second. I can see, yeah, that was what I was suspecting as well. I could snap some of those guys. You can see here there's some weird behaviors. There some characters which are nearly it's not nearly upside down. That guy is totally upside down. So in some situation that could make sense. I don't have any examples here, but maybe spaceships would be a good example. You don't really care about upside out. But here with bees, even if they're good flyers, that's not realistic. So that's probably something I want to change. The way I want to change that is, I guess, let me remind where it is. I will probably go for the flocking behavior. And let's check what I'm having. I'm having separation weights and probably within the advanced attributes. Here it is. So yeah, we got something which is called what's the maximum up angle you allow for the characters to be in. So here 180 degrees means that they can go upside down. So probably that's not something we want to have. So what's the maximum Y angle a bee can have? So that's probably something like 45 degrees, I guess. Not really sure about that one, but let's say something like that. And now it means that we're gonna clamp the values, whatever the trajectories the characters are following. We're gonna keep them in a maximum 45 degrees angle. So yeah, that's way better here. Okay, and also if you wanted them to bank, because they're not banking too much here. So banking means how much you're gonna orient when you're gonna be into a curve, like planes will do when they turn. They actually bank. So here means that it's gonna be, I guess it's a ratio. So yeah, it's a ratio. So between 0 and 1. So 0.1 means that they bank by 10% of the actual orientation of the curve. Okay, so well, it's probably bigger for bees, but I'm just trying to show how does the behavior looks like. It's really up to you here to play with the different parameters. Something we haven't really played with is probably the last behavior I'm going to play today. It's going to be the perch behavior. So here's some, you can see, yeah, there's a mesh here, and probably it's a hive, and probably some characters will have to perch on that hive here and maybe move on top of it. So to do that, we're having something which is called the perch behavior. So I'm gonna bring it here and put it into the parallel mode here. But I'm gonna probably trigger it at a specific time within the simulation. So I'm gonna let's take a look at how it looks like. So first, it's asking me, so what are the perching support? So it's expecting to have some geometries here. So what are going to be the 3D geometry you want your characters to be able to land on? So I'm going to use the hive for that. And I'm going to press Shift while I'm selecting the cylinder to be able to keep my selection here. I'm going to map this here as well. Also, it's asking me, is it going to be dynamic as a perching support? So it's not. Is it going to be deformable? It's not neither. Do you want your characters to perch at random orientation? Yes, please. And what's going to be the landing distance? So when landing, the characters will face. It means that their y-axis, their up axis, will face the actual normal of the geometry. And free here, it's a unit, so it's a 3 meters because I'm using the default units here. So that means 3 grid units if we take a look at the grid. And it means that during 3 grid units, the character will face the actual same normal than the geometry they're gonna land on. What's going to be the landing speed? So what's the speed when they arrive? So it's going to be probably 0. And you can also ask them to take off. So that behavior, when it's on, it's going to perch the characters. And when it's off, they will take off automatically as soon as they got some steer and flocking behaviors. So keep in mind that when it's on and it's triggered, it will be, it'll take control on top of the flocking and the steering. And when it's off, it will just take off here. Also, we got something which is called perching raycast distance. So what's the distance under which we consider that a character should perch? So 3 units is not that big, so probably we'll have something like, I don't know, let's try a big value here. And I only want to start, so it means that, sorry, just a quick word about that. It means that whenever a character is next to one of those meshes, and that's the y-axis is going to be into the direction of that mesh, and that mesh is at less than 100 units, what trigger will start perching onto that geometry here. And I don't want that to happen. Well, let's see how it goes maybe. And I'm going to trigger that maybe a bit later. So now I'm having my characters following. Yeah, okay, not so bad. I actually haven't defined anything yet. So here from the beginning, they decided to land onto the beehive, sorry. So well, probably not bad. Let me change maybe the triggers. So you can see here and there are some characters, if I let the simulation run again and again, you can see here and there, some characters will just join the group by perching. They're joining because at some point the flocking behavior bring them into the close range of the geometry, and the close range being defined by the raycast distance, and when they actually reach that point, they just start perching. Maybe I can play with this and also ask them to, take off at some point. So yeah, maybe we're gonna end with that. So I'm gonna add here a stopping trigger, and I'm gonna ask the characters to stop perching after, I don't know, like a specific frame. Let's say frame 600. So I'm gonna play with the frame trigger here. I'm gonna set it as roots, and what I'm gonna do is say whenever the frame reach value 600, I want my characters to take off, and the takeoff time will be, so takeoff distance is going to be the opposite of the landing distance. How long does it take to go back into the previous mode? And the stop action is actually taking off, so that's correct. So let's see how it goes. We'll throw the sun here. We'll probably have a few characters like landing within the first 600 frames. Yeah, we can see that guy here. Okay, so that's frame. That guy here is totally perching, and let's wait to see until frame 600 what's going on, and see what okay, it was a bit too far. And yeah, by the way, you can notice that my characters, they stopped like having that a wing animation. Maybe I should say a word about that because I totally forgot that I did it. So yeah, you can see the characters after frame 600, they just went back into flying within the other characters. Just a quick word, because I was surprised to see that my characters were actually stopping flying as soon as they were perching on. And that's because I used my scene, the final scene, as a base to create that init scene. I just remove some of the stuff, but yeah, okay, sure. Here we go. So on the stopping trigger for my flying behavior, so this is this is my procedural flying wing animation here, in which I put my curves and my different weights. That stopping trigger, so when does that behavior stop? And that behavior stop when a specific channel returns 1. And actually that channel is one of the channel we provide, which is perch target reach. So we're just saying that as soon as the character is perched, please stop playing that fly animation. So that's why my characters there were stopping playing that fly animation, and I had a stuck character. Totally forgot about that, and was kind of surprised to see that happening by itself. I thought that was kind of magical. So yeah, here it is. Maybe we can use that scene as a starting point for discussions if you have any. So that's a good time, if you got questions, to put them into the chat box. Also, as usual, feel free to let us know if you're new to that channel. Feel free to let us know where you're from. And also, we'll be interested to know what are your positions right now, if you're actually working, not working. And if you're working, what's your title? What do you do? Are you a crowd TD, or are you just a generalist? Well, not just. Are you a generalist animator? Let us know. We just want to know who are the people we're talking to. So yeah, let's have some quick questions. I can see there are a few into the chat box. So what would happen at the end of the curve with loop at end of curtain off for a curve that's not closed? That's pretty easy, that one. So the question is, here you can see my curve is kind of the start point and the end point are kind of next to each other. So it means that when the behavior reached the final position of the curve, as I said into the steering behavior, that they could loop at the end of the curve, they just then reaching the starting point. So let's say you got a bigger distance, your characters will just use the first point of the curve as a target, and they just go through the environment and reach the first position of the target and go through the curve again and again. So will they fly back to the start of the curve? Yeah, totally. On a straight line, well, on a straight line, kind of, following the flocking attributes you specify to them. Or will they ping pong on the curve and fly back using the same curve path? No, they're not looping, and actually that would be kind of a nice maybe feature to have something which is called like indeed, you got some controllers within Maya which is called like looping or ping pong. Means that when they reach the end of the curve, they can just go back and follow the curves in the opposite way. If you had to do it right now, there's nothing which is embedded into the system to do it. You probably will have to make a specific curve, which follow itself back and do the ping pong yourself. Yeah, people from Mexico. Okay, are there more questions? So in the meantime, if you have any questions, it could be about the flock or about anything else. In the meantime, let me remind you that we're gonna do some battle sessions starting next week with a lot of physics, with archery soldiers on Thursday and charging armies on Friday. Probably using some nice triggers, maybe perceptions as well, and triggering some animation when characters get close to each other. So stay tuned. So people are generalists focusing on crowds. People, TD and R&D department. I know that there are some animators as well. Okay, it looks like flocking didn't inspire much questions, or maybe my presentation was really good and you didn't want to. You didn't require more information here. FX people, artists. And okay, that was probably one of the shortest sessions we made. So just let this running for just a few minutes if there are more people who are interested into or are more questions, or if you want me to do something specific into my scene and changing that, go ahead. And else, the good news is here on tomorrow is going to be a bank holiday, so right after that, it's weekend for us. So if you don't have any questions, that's good news for me. It means that it's my end of the week and I can just have some rest. Okay, all good. So let's wrap it up. Will be a short session today, which is good as well. Subscribe to the channel if you haven't done so. You can grab the software on our website license, which just means that you're gonna have some watermarks at rendering. But apart from that, you can use the same features, and we're gonna probably pack that asset we're having, that B asset, and also pack that scene as well. I'll probably add some physics. I wanted to have some bees flying around. Oh, you know what? I know what I wanted to show maybe as, you know what? If you still have 5 minutes left, let me show you something else. Something people don't really know about, and, it's probably your fault because we were saying a lot that flock behavior is only for 3D creatures. Maybe you noticed that on the flock environment, which I have selected here, I've got a chat box, which is disabled by default, which is called is2D. And as soon as you check this, you can see that my spheres, which was my environment, now looks like just only circle. So that's 3D, 2D. And now you're saying that the characters are only going to be animated on the 2D space. So let's say you want to make, herds of animals, and you want to control your animals and your navigation with those parameters, which is cohesion, alignment, and separation. That's exactly the way you do it. And you can probably add like a terrain. Let's bring a terrain geometry here. And I can sculpt that a bit if I wanted to make some relief and have characters following this and say this is going to be my terrain here. And even if the characters has been emitted in 3D, when the simulation is going to start, you can see that the characters now get snapped and attached to that ground geometry, but they still follow the rules which I've been providing them to. So you can see they follow the curves and they still go to the beehive and wander around. So yeah, just a convenient way to have something more organic when you do stuff like 3D animation for animals, all that kind of stuff. And just a side word about that, that algorithm I was speaking about in 1986, which was released, one of the first uses for that algorithm was within Jurassic Park, when you got that, I can't remember the name of the dinosaurs, but the one which were herding in the hills, and they were going towards the child. Gallimimus, that's the name of the dinosaurs, and that's exactly also the same algorithm which was used in The Lion King, the first one. The animated one, 2D animated one. They were using 3D animation for the first time, and they were driving the position of the characters using that flocking steering behavior. So that's exactly the same stuff here that we've been reproducing. So that's why it's pretty convenient when you want to make 3D animals or even 2D animals which are actually adapted to the ground. Okay, so that's a wrap. Indeed, it's beer time for us. So in the meantime, you guys take care. See you next week for more sessions about, once again, battles. And grab the software on the website if you haven't done so and play with it. We'll be happy to help if you need to make some specific use case or prediction sessions. So see you later and take care.